Okay. So in the last class, we learned about bubble sort. I hope you all are clear with that. What actually sorting is nothing but, and how the bubble sort will be working. We have learned through an example, and we have concluded with the code. 1 second. Okay, so today we'll see about selection sort. We are confining ourselves to bubble sort and selection sort only. So bubble sort you already learned. We will be accepting from the user some unordered set of data values, and we have written the code for the bubble sort. And if that input is processed through that code, you will be getting the sorted order. So we have learned about descending order. So the same approach, let us see today the selection sort, same thing for this. We'll be accepting as input um, unordered set, unordered set of values will be accepting, and as an output, we will be displaying ordered set of, right? So this is what we'll be doing today. And what is the approach for the selection sort? I'll tell you. So let me explain you in detail. If let us consider we are storing 5 values. We are taking an array of 5 elements. Okay. Now let us consider this is an array A. Now this array index is, this one is 0, this one is 1, and this one is 2. This value is 3, and this array index is 4. Got it, all of you? Now what is the approach in the selection sort is, we need to start with the first element. We need to start with the first element. Now, this first element we need to fix, and we need to check from the rest of the array the smallest value. And once we are getting the smallest value, suppose this element you got the smallest value, then this smallest value should be swapped with this index. Got it? Now, once you are fixing this one, we need to come now start with this index, and then remaining 3, whatever we have from this list, we need to get the smallest value. And suppose this is the smallest value you are getting, and then this value should be swapped with this value. So that means in each iteration, we are fixing the smallest values to the left hand side. Remember, bubble sort, what we have done? Bubble sort, we have swapped, we are comparing these two pairs first, and then these two pairs first. These two are compared first, and then these two are compared, and then these two are compared. That is the bubble sort. So that is not the approach for us. In this selection sort, what we are doing is, we are fixing our first index, and then from the remaining set, we are selecting the smallest value, and then if let us consider this is the smallest value you have found, then this value is swapped with this value. Got it? So for one iteration, we will be getting the smallest value. Remember, we are confining. Our approach is to produce an order in the ascending order. That means a smallest value will be here and the largest value will be here. Okay, to make this one more understanding, let me show you one animated thing where it will be more understanding for you. See this one, all of you. Is this screen clear to you, all of you? Is it visible? Is this screen visible to you all? Yes. Now, if you see, randomly we have collected, we have taken some set of values. Now, we are learning the selection sorting, where in the selection sorting, what happens is, for the first time, we will be taking this value, and from the remaining list we will be selecting the smallest value. How to do that task, that coding part I'll tell you, but first understand the approach, all of you. We need to take the first element, and from the remaining list, from this value 43 to 76, we need to find out the smallest value. See here, with the thing that is highlighted with the red is the smallest value. Once it is found, what we need to do? We need to swap this value with this value. So the next thing is swapping these two values. So now this value has been fixed. We need to move to the next value. What is this next value? I plus 1. That means I equal to 1. So we are now at this location. Now from the remaining set, we need to find out the smallest value. And that smallest value in this example is 5. Now we need to swap these two values. Got it? In the next iteration, this is the I value. See, at each iteration, we are getting the smallest value and we are fixing the smallest value. So we are not touching this array, this part, this sub-array. Now we are in this iteration, I equal to 2. Then we need to get the minimum value from the remaining list, that is 12. Again, we need to swap. Same way, this is fixed, 12 is fixed. I equal to 3, we are swapping these two. Okay, next I equal to 4, we got 21, the smallest value, we need to swap this one. I equal to 52, I equal to 5, value 52 is need to be swapped with 35. In this fashion, you need to proceed. So I will show you one iteration. So I think this is up to here, it is clear to you all. Now if you see, yeah, we are as performing, we want to do in the ascending order. If you see here, 84 is the smallest, I equal to 11 is the 84. So from the remaining list, no value is there smaller than the 84. So no need to swap. Got it? I equal to 12. I equal to 13. I equal to 15. I equal to 14. So we are at I equal to 14. Okay, so we have stopped our approach here. So can you tell me what is the approach we are doing? We have started from I value from 0 to number of values minus 15. So let me divide my screen like this. So I can write the code parallelly. Yeah. See, it is not like I have not told like this algorithm is best than the bubble, so that is not the case. Okay. Now, let us write down the code for this one. So, what is the code we can write? Follow carefully, all of you. We need to perform some operation for starting value I equal to 0 to I value we are here, right? So we need to perform this operation from I value 0 to I less than n, or else you can write I less than or equal to n minus 1 also. Number of elements minus 1. We have not reached our I value here because one element is there, no need to move to the next one because after that we don't have any other value. Okay. Now we are performing some task here. We need to write some logic in between these two. Now, if you see, I will reset this one. For the first time, we are here. Now, from the remaining list, we need to get the smallest value. So, for that, what we can do? We need to repeatedly check this value. We need to check repeatedly this value with this value. Isn't it or okay? So, for that, what we can do? Let us take another loop. J equal to, can you start? Let us consider this is the index J. Don't get confused. This index is J. Now, what is the J index? I value is 0. J index is 1. That means J value will be I plus 1 only. Very good. I plus 1. And how many times the J has to be repeated? How many times the J has to be repeated? See, it has to be going on, increasing like this. We need to compare up to this element, isn't it or not? So, what is this element? Yeah, n minus 1, not n minus 1, j less than or equal to n minus 1 or j less than n. Uh, yeah, this iteration we will, this condition, we will see if it is not working properly. Let me change the condition. But for the time being, let us write like this. Okay. Now what we have to do in this for loop, can anyone of you tell me? We need to check this value with this value. Okay. Now how you are checking this one? If we let us consider this array is A of j, okay, is less than A of I. Are we comparing like this? We are checking A of j is less than A of I or not. Okay. If it is less than A of I, let us store this index value uh, in some variable. Let us consider min. Let us min index. I am storing the index only. So I am storing the index of j, because suppose this first element value is less than the zeroth element. I want to store this first element value index, that is 1, in minimum. Why I am storing? Because why I am directly not swapping? Because there may be a chance like this value can be smaller than this value. We should not confine here. This value can also be smaller. This value can be also be smaller. If you see from the total list, we got this value as a smaller. So once traversing through all the list, in the minimum, we will be having a value which is the index of the value which is having the smaller value. Okay. So now once this is confined, minimum value is confined, then what can we do? Then what we need to do? We need, let us consider this is the index we got. Now we need to swap this value with this value, isn't it or not? Yeah. So swapping can be similarly can be done equally. So instead of changing the I value, what I am doing is I will be storing this initial minimum value min equal to my I index only. That means I equal to 0. I am starting taking that one. But later on it will be updated like this. Okay. Are you understanding? So this is A of. Are you understanding what I am doing? For suppose for the first time, this is the minimum index value, that is 0. Okay. Now this A of index value will be compared with this value. If this is less than, then the minimum index value should be this one only, and this should be compared with the other values. Isn't it or not? So like that we are doing. Now what we need to do? I want to swap this value, and if we are proceeding in this fashion, we will get this value. So this index is stored in min. What we need to do? We need to do the swapping. How can we do the swapping? The swapping can be done by writing like this. This loop will be repeated continuously. See, if you have a single statement, no need to put the like this. Got it? Now for all these iteration, that means of crossing all these two, you will get the minimum index of this minimum value, index of this minimum value that will be stored in this. Now what we need to do? We need to swap this one with this. That is the thing we are doing. So how can we swap that one? We can, let us take one temp variable, temp equal to, what I will do is A of I will store in that temp. That means initially I value is this one, and then now what I'll do, in the A of I will get the A of minimum value. Okay, and in A of minimum I am storing the temp value. This swapping logic you all are clear, because in the yesterday's class we learned that. Okay, so this is how. So this is for I equal to 0 we have done. Now for the next iteration, what happens? I value will be 1. If you see, I value will be 1. Now minimum value will be 1 now. Okay, minimum value will be 1 now. Now for I equal to j plus, for j equal to I plus 1 means j will be starting from here. Okay, and then A of j will be compared with A of minimum value 20. If it is less than, then minimum index will be shifted. It is not the case. Now this j will be now here. J will be now here, here, here. For all these cases, this is not satisfying. It will be repeating the loop. J is here, 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 here. Now it has reached in this case. Now a of j is less than a of minimum value. In this case, what happened? Minimum index has been updated to this index. What is the index of this one? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the index. So minimum index will be 12 now. Now minimum index is 12. Now j will be incremented. J will be now here. It is compared with this one. No, now j will be here. J will be here. Got it, all of you? Understood? So this is how. So we need to check less than or equal to n, I think. Right? J will be here. So this index is what? This index is n minus 1, no? So less than n minus 1. That, it is correct now. Okay, now the minimum in we got this minimum index. Now after traversing through all the iterations, now we got the minimum index. Now after this, what we have done, we have to do the swapping, which we are doing like this. Now after swapping is done, we need to go with the next iteration of I. So what happens? I will be shifted to here now. Got it? This is how the loop will be executing. Okay, here can you tell me this is the index is here 0. The index here is n minus 1. How many times I value we are repeating? Can you tell me? See, if you traverse like this, I value we have stopped here. Total we have how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Total we have 16 values. Got it? Indexing starts from 0 to 15, but we are stopping at 14. That means if you see here, I value should be n minus 1. Are you understanding why I have written n minus 1? Why? Because we have total of 16 elements and the indexing is starting from 0 to 15. Okay, 0 to 15. Okay, and then we need to stop at 14. N value is 16. We need to stop at 14. So that's why I have written I less than 15 minus 1 is 16 minus 1 is 15. I less than 15 is nothing but 14. Understood, all of you? This is how we need to stop here. So the indexing starts from 0 to 15. We need to stop here. That's why I value has been written like this. And J value, we need to proceed from this value to this value. That means I plus 1 to I plus 1 to n minus 1 we need to proceed. So that's why I've written n. Understood? So this is a small logic to perform the selection sort. If you found any difficulty in this, you can ask me. If you are not able to understand, I'll explain one more time. Okay, I'll explain one more time. But this is the logic behind the selection sort. Are you understanding what is the reason behind this n minus 1 and n, and why we are checking and why we have taken the minimum index value and why we are performing the swapping operation? This should be clear to you all. Is this clear, all of you? See, I'll explain the code one more time, how we have written. We are starting from our main approach of, our main approach is to perform the sorting, where we are giving the unordered set of values and we need to get the sorted order, and we are writing the logic to get the ascending order. Got it? Ascending order is nothing but this value will be the smallest value and this value should be the largest value. Now, how the approach will be is, the approach is we need to start with this position and we need to check the minimum value of this complete list. And wherever we got the minimum value, that the value should be swapped with this first value. So that means starting from I equal to 0, we need to get the minimum value of this one. How to get the minimum value of this one? We need to take this value. Let us store this value as this value as j. Now j value will be always equal to I plus 1 only. That's why we have written j equal to I plus 1. About this condition, I'll tell you. Okay, first j value is less than I plus 1. Now, initially before traversing, let us call this is the index which is having the minimum value. So I am taking the minimum index value is I value only for the first step. Now what we need to do, we need to check this j value indexed value is less than this minimum indexed value or not. So a of j is less than a of minimum. If it is like that, then minimum index should be updated to j. If this is, let us consider this is 5 value, then minimum index should be 1. Got it? And now again j value has to be incremented to the next value, this value. This now we are at this location j equal to 2. Now we need to check this a of j60 is less than a of minimum indexed value. As of this example, our minimum indexed value is this one only. Are you understanding? This one only. So this is not less than. So it will not go into this if statement. Now j value will be incremented and this is the j value. If you see here, a of j, that means 0 is less than a of minimum. Minimum is as of now I only. We have not updated this one. So now what happens? These two will be swapped. These two will not be swapped as of now. Minimum index will be changed to this location. Make a note of this one. Minimum index is now here. Now j value will be incremented to this location. Now this value will be compared to this value because minimum index is this one. So it is already less than. So no need to update the minimum index. Now j value will be this one. J index is this one. No, not less than. So minimum will not be updated. So it will traverse like this. Once it is traversing all the elements, we need to traverse all the elements. That means the indexing starts from I plus 1 to n minus 1. So that's why j we have written less than n. Okay, if you are getting confused, you can also write like this, equal to n minus 1. Less than or equal to n minus 1 if you are getting any confusion. Now the minimum index is this one. After this, what you need to do? This one is done. We need to perform the swapping operation. So we are doing the swapping operation. Got it all of you? Now this is for one iteration of I equal to 0. Now the next iteration is I value should be incremented to here and we need to proceed with the same logic. Once this is done, the swapping will be done. Like this, it will be proceeding. Now, how many times the I has to be repeated? If you see here, the I has to be repeated. The I has to be repeated up to here. That means I value is 14 now. In this case, the indexing starts from 0 to how many values? We have 16. 16 elements is nothing but n value is 16. 16 minus 2 is nothing but 14. But I have written less than. If you are writing less than or equal to, you need to write equal to n minus 2. For your simplicity, you can write like this. That means in this example, n value is 16. This loop will be repeated from 0 to 16 minus 2 is 14. Understood? Got it all of you? So this is how selection sort will be done. Now what you will do is you all practice on your compiler whether you are successfully getting the output or not. Be online. Don't exit the meeting. I'll execute this program. If no errors are there, I'll show you the output. Meanwhile, you also practice this one. Yeah, what is your someone is having a doubt. What is that? If you have any doubt, you can put it in the chat box. Now, meanwhile, I'll execute this program and I'll show you the output. Someone has asked like, ma'am, what if the if fails? See, if the if condition is true, then only the minimum value will be updated. If the if is failed, then whatever old value you have for the minimum, it will be as it is. The minimum value will not be updated with this one. Now, this swapping is out of this for loop. So what we are doing here, we are finding the minimum index value. Now, after traversing the complete list. Got it? After traversing the complete list, we are finding the minimum index value. Once the minimum index value is found, then obviously this will be done. Swapping will be happening because This swapping is out of this for loop. See, this for loop is only to find the minimum index. And from here to here, we have the for loop for I index. Got it? Don't get confused. This logic is to find the minimum index, and after getting the minimum index, we are swapping this one. So this is in between this for loop. Okay. So let us execute this program now. Now we need to declare some variables. So let us declare array A. I think we require J minimum. Okay, 10. In future, if any variable is required, let us come back and declare here. Okay. Now what we'll be doing now? We need to, sorry. We are asking the user to enter the size of array. Okay. Meanwhile, you also write the code for this one, all of you. So n, we need to declare n, I think. We need to declare our n variable. Okay. Now, these two lines of code is used to ask the user to enter the size of the array. Now, I'll be reading the array values. So, for reading the array values, can you tell me what we need to do? One-dimensional arrays, how we are reading? Any one of you? How we are reading the array values? Very good. We need to use for loop. I equal to 0, I less than n. Why? Because indexing starts from 0. Okay, I plus plus. We need to write scanf percentage d. Because we are storing integer values, the format specified is percentage d. So we are reading the values. So this logic is to read the values from the user, array values and values. Now once this is done, what we need to do? We need to perform the sorting. So let me simply copy the code which I have written here. I think I need to for I equal to 0, I less than n minus 2, I plus plus. The code is right now. Now I'm writing minimum equal to I, because I want the first minimum index should be stored in min variable, for j equal to I plus 1. This is right now. Okay. Now let us come here. If a of j is less than a of min, right? We are storing in the min variable, right? Now this is for loop. Now we are writing temp equal to a of I, and a of I is equal to a of min. Somewhere if I miss semicolon, you please tell me. I'll change that. Okay. This is the end of this for loop. Okay. And finally, this is the now this is the complete logic to perform the sorting selection sort. Now once this is done, we need to print the sorted list. So let me copy this one. Enter. Sorted array values. I am printing A of 5. Got it, all of you? So let me run this program. If any compile time errors are there, it will be shown. So I think there is an error. Where is the error? Okay, enter the size. It is asking enter the size. I have given size 5. Let me give the 5 values like this. Okay, there is no end for this loop. Oh, where I have done wrong? This is right now. Where I have done wrong, can you tell me? I have to read 5 values only. I less than n. This one. Okay, this is print, no? Very good. Thank you. So now it is asking for an array size. I have given 5 and now I am giving the values like this. Why it is still reading the values? Somewhere there is a mistake. Yeah. All of you practice this problem. Okay. Practice this code and check the output. So with this we have come to the end of our selection sort. So we have learned bubble sort and selection sort.